Hello again, friends. I hope you are all doing well. Today we are starting with chapter 4, applications of derivatives. As you know, we are done with chapter 3, that was all about derivatives. In chapter 3, we were talking about the rules of differentiation, the rules that will yield to the derivatives of trigonometric functions, hyperbolic functions, and exponential functions, logarithmic functions. We found all those derivatives. We also we used the way of logarithmic differentiation to find the derivative of some complicated functions. Today we are coming to chapter 4. It's about applications of derivatives. How do we use those derivatives? Where do we use those derivatives? What are we gonna find with those derivatives that we have studied in chapter 3? So the first section of chapter 4, we have got extreme value of functions. What are extreme values of functions? We have got in general maximum values and minimum values for the function. Of course, when we are talking about a function, it may have a maximum value or a minimum value or both of them. The first definition that we have got is we have got a function f. Sorry, we have got a function f, okay, that is given on the domain D. That means that function has got domain D, it is defined on that domain. Then we say that that function f has an absolute or global maximum. Okay, either you say absolute maximum or global maximum, it gives the same meaning on that domain D. So that f has got a maximum value on that domain, a global maximum value on that domain D at a point if f of x is less than or equal to f of c for all x in D. What does that mean? That means if we have got something like that, for example, if I'm having that graph of function, let me explain it here. For example, I'm having a function like this, okay? That function is defined on that domain, okay? A and for example B, or even we can say that, okay, let it be that function. Okay, we say that that function has got a maximum value or global maximum at that point, okay? That is the same C that is written in here, okay? If all of the other x's are less than or equal to f of c. What does that mean? That means if I choose a point here and find its f, choose another point here, okay? For example, I choose A, I choose x1, x0, x2, x3 till the point B. If I put all those numbers in the function f that I have got, all those numbers will give me a value that will be less than that point, okay? That c that we have got. Since that one is, or we can say that f of c is greater than or equal to all of the other values of f. Since it is greater than all of the other values of the function, so we say that that c is the global maximum for that function, okay? Now we have got global minimum or absolute minimum for the function D. So here we have got absolute maximum, and the rule is that. Now we are coming to absolute minimum. Okay, absolute minimum. What's the rule for absolute minimum? We say that f of x is greater than or equal to f of c for all x in D. What does that mean? For example, that is the point that we have got, the minimum point, that was the max point, okay? That's the min point. How do I know that this one is the global minimum for that function? Because whatever x I'm taking in the domain of the function, if you look at the domain of the function, is on that interval from A to B. Whatever number I'm taking from the domain function and I'm evaluating its function, I mean, I'm putting it in the function and evaluate it, all of those numbers will be always greater than or equal to that minimum value. Since this one is less than or equal to all the other values, so that point is called the global minimum for the function, okay? We are given an example here. It's page 24. If we are given a function cosine and sine, let me draw both of them separately. Okay. If we are having that function cosine on the interval of minus pi over 2 to pi over 2. Okay, so what's the interval that is given to me? The cosine function, that's cosine of x, is given to me on the interval minus pi over 2 to pi over 2. If you look at that function, what is the minimum point of that function? We have got two minimum points, minus pi over 2 and pi over 2, okay? So that ones are global minimum for the function. Why? Because whatever number I'm choosing in the domain of the function and I'm putting it in the cosine function, it will be greater than those two numbers, okay? So minus pi over 2 and pi over 2 are global, okay, or absolute global minimum for the function f. How about the maximum value or the global maximum for the function? That point in here, that is 0, okay, here we have got 0. When I input 0 into the function cosine, I'll get the value 1. That one is greater than or equal to all of the other values that are in the domain of the function. So 0 is what? 0 is the maximum point or global maximum for the function cosine on that given interval. Let me draw a sine function on the interval minus pi over 2 to pi over 2. If you look at that sine function, here y is equal to sine of x, what is the minimum value or the absolute minimum for that function? It is that point, okay? Where does the minimum value occur? On the point minus pi over 2. So minus pi over 2 here is global minimum, okay, or absolute minimum, doesn't make a difference. Why? Because whatever number I'm choosing from the domain of the function and I'm putting it in the sine function, that will be the smallest value, the smallest value for that function. How about the maximum value for that function? It occurs at pi over 2. So pi over 2 is absolute or global maximum for the function. Why? Because again, if I choose whatever number in the domain of the function and I put it in the function sine of x, that will give me the highest value, which is equal to 1, okay? And here for that one is equal to -1. So that is what? That is a global maximum and global minimum for the functions sine and cosine. We've got example 1, okay? Example 1 in the course material, how to find or the general idea for finding the absolute minimum and maximum for the function x squared given different domains. If you look at the function x squared, if I have got y that's equal to x squared, and if it is given on the interval minus infinity to infinity, okay, so the domain is negative infinity to infinity. Let us sketch the graph of this one, okay. If I sketch the graph of x squared, how will that be? It will be something like that, okay. If you look at this one, of course this one, since it is going till infinity, okay, so that one is going till infinity, okay, and here since it's getting to negative infinity, the domain, so this one is also extending from here. If you look at that function, do you see any absolute maximum or any maximum point for that function? No. Why? Because this one keeps going on. It doesn't have a bound. Since it doesn't have a bound, so it has got no, okay, global maximum, okay. How about minimum value? If you look at that function, Where does the minimum value occur? It occurs at 0. Okay, why? Because whatever other numbers you're inputting in the function x squared, 0 will be the smallest value for that function. So 0 is the x equal to 0, of course. X equal to 0 is the global minimum for the function. That's part A. Let's see part B. Of course, again, the same function is given to us, but on different domains. Okay, what is the domain given to me here? The domain that is given to me is between 0 and 2. Let me sketch the graph of the same function on that interval. Okay, how is the graph of x squared? It is the same thing as this one, but here the domain differs. It is from 0 to 2. So the graph of that function that I am drawing, it will start from here. I will not have that part of the function because this is not included in the domain of the function. So I'm starting from here, okay, and I'm going till there. Why? Because here is 2. The domain of the function is between 0 and 2. So that will be the piece of the graph of the function. If you look at that function, where do I have minimum value? I have got a minimum value at 0. So x is equal to 0 is global minimum, okay, because that's the minimum value for the function. How about the maximum value? Since 2 is in the domain of the function, and that is the highest point for the function, so x is equal to 2 is global maximum, okay. Here, when we had the domain of the function that was between negative infinity to infinity, we didn't have global maximum because that one was keep going on. We didn't have a bound for the function. But here, since we have got a restricted domain, we are having global maximum and global minimum for the function. Now part C. Again, we are given y that's equal to x squared, but this time the domain is between 0 and a closed interval of 2. That 0 is an open interval and 2 is a closed interval, okay? Let's again sketch the graph of that function on the given interval, okay? So again, if you look at that function, the difference between this function and that function is only the 0. Here it is included, but here it is not included, okay? In the previous function, if you look at it, here the 0 is included in the domain, but in that one, it's not included. So I'm making a hole here. Instead of darkening it, I'm just leaving a hole here, and the function goes from here to there. What is the domain? From 0 to 2. 2 is also included here, okay? So I have got a point here. If you look at that function, do I have a minimum value? No, I do not have a minimum value. Why? Because here 0 is not included in the domain of the function, so I cannot say that 0 is the minimum value for that function. So the function that I have got here has no global minimum. But if you look at the maximum value, that point 2, when x is equal to 2, gives me the highest value for the function x squared. So x is equal to 2 is the global maximum for the function that we have got. Let's move to part D. I have got again the same function, but the domain is the open interval of 0 and 2. Let's sketch the graph of this one, of x squared again, on the given domain, okay. What do I have? 0 is not included in the function, so I'm making a hole here, and here again 2 is not in the domain of the function, okay. 2 is not in the domain, so I'm making a hole also here. If you look at that function, I do not have 0 in the domain, so I do not see any minimum value here, so the function has no global minimum. If you look at that function, if I had 2 in the domain of the function, this would have been the global maximum, but since I do not have it, so it has also no global maximum. Since it doesn't have global maximum or global minimum, so in general I can say that it has got no global extrema. okay? Or instead of global, what can I say? I can say absolute extrema, okay? That to give the same meaning. What is extrema? When I say find the extrema points for that function, that means find the maximum and minimum. So in general, when we say extrema, it includes both of the minimum and maximum, okay? That's all about extreme values, okay? In general, we have got a theorem. It states that if, let me write it for you, a theorem. It's for extreme value. It's called extreme value theorem. What does that theorem state? It says if f is, I will write it in a short way, okay? Not writing all the whole explanation. F is continuous, okay, on a given interval, given closed interval, not any interval. If f is a continuous function on a closed interval a and b, then f attains to have both maximum and minimum values. Then, okay, I will write this in like that. Then f will have relative, sorry, not relative. F will have global extrema. Okay, what does global extrema mean? That means global maximum and global minimum. So in general, what do we have from that theorem? What do I get? I have got a closed interval, a and b, and I have got a function that is continuous on that interval. Then I will definitely have that f. I'm sure that that f will have global extrema, maximum and minimum points. Okay. Now we're moving to local extreme values. Local, let me write it here. We say local or relative extreme values. Okay, here we have got local, or we say relative extreme values. What are local or relative extreme values? That means local maximum, local minimum values. Previously we studied global maximum and global minimum. When we are talking about global maximum and global minimum, we are talking about the whole domain of the function. Okay, we are not we are not dividing the interval that we have got into sub intervals. Okay, we are talking about the whole domain of the function. But here we have got local maximum and local minimum. We are looking at sub intervals of the whole interval. So if you look at the definition of the function, we have got a function f. Again, it has got local maximum at a point c in the domain of the function. Again, if f of x is less than or equal to f of c, that means that c, when I'm putting it in the function, is greater than or equal to all the x's in an open interval containing c. Previously we said for all x in the domain of the function, but here I'm saying in some open interval containing c. And of course, a function f, again, it has got local minimum or relative minimum if f of x is greater than f of c for all x in some open interval containing c. Again, what does that mean? That means the c that I have got, when I'm putting it in the function f, will be less than or equal to all of the other values of f in a given open interval, not the whole domain of the function. If I give you that thing in here, let us locate the maximum and minimum values. Here I have got a max value, here I have got a max value, here I have got a maximum value, and here we have got a minimum value, minimum value, minimum value. Let's make a difference between, let's look for the difference between the local extrema and global extremum. When I'm talking about the global maximum and global minimum, I'm looking at the whole of function, okay? So the domain that I have got here starts from A to B, okay? I'm looking at the whole function. What is the maximum value, okay? The global maximum, the maximum value for all of the function. If you look, this one is the highest point, okay? So I will call this one as global maximum because it is the highest point in the value in the function, on the domain of the function. How about what is the minimum value for that function? If I look at the whole graph of the function, I see that those ones are minimum values, but what is the least one? That one is the least value for the function, so that one is called the global minimum because it is the minimum value for all the function, the whole function. How about if I come to the local maximum and local minimum for the function? I'm dividing that function into sub-intervals, okay? I'll make this one into an interval, that one into another interval, okay? So that one is an interval, this one is another interval, okay? Let me do it like that so that it will be more obvious for you. I will make this one from here to here another interval, from here to there another interval, and so on like that. Okay, so I have made that interval, the whole interval, into sub-intervals, and I'm looking for the maximum and minimum values in each sub-interval. Okay, so when I'm looking for the maximum and minimum values in each sub-interval, that means I'm looking for local maximum and local minimum for the function. Okay, let us look at that interval. Okay, from A to that point, let's call this one x naught. Okay, from A to x naught, what is the minimum value for that function? That's the minimum value. So I will call this one as what? Let me write it with a red pen. Okay, that one is local or relative minimum in that interval because it's a minimum point for that interval, not for the whole function. Okay, let's come to that interval from x naught to x1. If you look at that function in that interval, it has got a maximum value. That maximum value is only valid for this interval. So I will say that this one is relative maximum. Okay, look, it is relative maximum and also global maximum for the function. But for that interval, I will call it relative maximum because I've chosen that point for that interval. Now, if I look at that interval from x1 to x2, if I look at that interval, what do I see? I see a minimum point. Since I see a minimum point in an open interval, sub-interval, so I will call this one as relative minimum. Again, this one is relative minimum and global minimum for the function. Now I'm looking at the function from x2 to x3, that interval. What do I see again? I see a maximum point. So that one is called what? It is called relative maximum for that interval. It's a maximum point for that interval. Again, I'm looking at that interval. For each sub-interval, I'm checking for maximum and minimum values, okay? In that interval from x3 to x4, I see a minimum point. So for that interval, I will call this one as relative minimum. And in that interval, that one is called the relative maximum. Look, each point from each interval we've chosen is relative minimum, relative minimum, relative minimum, because these ones are sub-intervals of the whole domain of the function. Relative minimums can be global minimum, but global minimum cannot be the minimum point for each sub-interval, okay? It's for the whole function. Okay, so that is the difference between local maximum, or you can say relative maximum, and global maximum. Global maximum, we said we are working on the whole domain of the function and looking at the maximum point. But when we are talking about relative maximum, we are looking at each sub-interval to see if we have got maximum points or not. The same thing is true for global minimum and relative minimum. global minimum, we are looking at the whole function and choosing the minimum point for the function. But relative minimum, we are dividing the function that we have got into sub-intervals, and we are searching if we have got minimum points or not. How do we find, or let us say the procedure, okay, procedure for finding extremas, okay, extrema. Of course, we're talking about global maximum and global minimum. Later we will study relative maximum and relative minimum and how to find them. How do you find the relative extrema, I mean the global extrema for a function? First, we have to find the first derivative of the function. Okay, so what's the first step? First step of the function, we are finding the first derivative of the given function. Second, we are finding those numbers in the domain of the function that makes the first derivative, that means the derivative that we found in the first step, the first derivative, equal to 0 or undefined. Okay, so what is the procedure? First, we are finding the first derivative of the function. Then the second step, we are finding those numbers in the domain of the function that makes the first derivative equal to 0 or undefined. Then the third step, we are evaluating, or I can say from here, those things that I find in here are called what? Those numbers that makes the first derivative equal to 0 or undefined, I will call them critical. Okay, critical numbers, critical points. Okay, that ones are critical points. So I'm evaluating, or the third step, evaluate the function that we have got at the criticals and endpoints. Okay, of course, when a function is given to you with a domain, with a closed interval domain, we have got endpoints for the function. Okay, we are finding the first derivative, we are finding the critical points for the function, and then the third step, we are evaluating the function at the criticals that we have found and the endpoints for the function, and then the highest values. Okay, highest values, we are choosing highest values, will equal to what? Global maximum for the function, and the lowest values will equal to what? The global minimum for the function. Of course, when you are writing the procedure or reading the procedure, it will be a little bit not very obvious, but when we are doing the examples, it will be easy for you to do. Okay, so the first example that we have got, it says find absolute, or what? Instead of absolute, we can write global. Okay, extrema of f of x that's equal to x squared on -2 and 1. So I'm giving a function f of x that's equal to x squared. The domain of the function that's given to me is from -2 to 1. What is required from us to find absolute or global extrema? That means maximum and minimum points. Let's give the solution. What are the steps? First, I have to find the first derivative of the function. Okay, so f prime of x is equal to what? Is equal to 2x. Then we are finding those numbers that makes the function equal to 0 or undefined. Do I have anything here that makes it undefined? No, I do not have it. So I'm simply finding those numbers that makes the first derivative equal to 0, okay? F prime of x equal to 0. What does that mean? That means 2x is equal to 0, and that gives me x equal to 0. What is that 0 called? We said here it's called a critical number. Okay, and then in the third step, what does it say? It says evaluate the function at the criticals, okay, at that point and endpoints. What are the endpoints? I have got this one and that one as the endpoints. So I'm evaluating the function, okay, not the derivative. I'm putting it in the function. I'm finding f of 0, okay, f of the critical number. I'm finding f of -2, and I'm finding f of 1. Okay, the endpoints and the criticals. F of 0, if I put 0 into the function, what will I get? 0 squared, and that's equal to 0. If I put -2 in that function, what will I get? -2 to the power of 2, and that's equal to 4. If I put 1 into the function, what will I get? 1 squared, that's equal to 1. What does the fourth step say? Now we have evaluated that we did the third step. The fourth step, it says find the highest value and the lowest value. If you look at here, what's the highest value? 4, okay, is the greatest value, okay, greatest value. What is the smallest value? 0 is the smallest value. So from the greatest and lowest value, what do we get? So we get that x is equal to 0, because we put 0 into the function, is the global minimum, okay? And for the greatest value, x is equal to -2 is global maximum, because it is giving me the maximum value for the function. We have got another example. It's again required from us to find the the absolute extrema for the function. We have got example 3. That was, I think, example 2. Okay. It says find again global extrema for f of x, or g of t is given. You can write it as f of x, doesn't make a difference. That's equal to 8t minus t to the power of 4 on the interval that's given to us, -2 to 1. So what are the endpoints that are given to me? -2 and 1. What do I have to find first? I have to find the critical numbers. So doing the solution, first we have to find the first derivative of that function. So g prime of t is equal to what? The derivative of 8t is equal to 8. The derivative of t to the power of 4, that's 4t to the power of 3. Now we are finding those numbers that makes the first derivative equal to 0 or undefined. I have got nothing that makes this one undefined. So 8 minus 4t to the power of 3, that's equal to 0. Finding just those numbers that makes it equal to 0. Taking this one to the other side, what will I get? I will get 4t to the power of 3 is equal to 8. Okay, I simply took this one to the other side, doing nothing more. And then from this one, I'm dividing both sides by 4, so I will get t to the power of 3 is equal to 8 divided by 4 is equal to 2. Taking cubic root, here I divided both of the sides by 4. Now here I'm taking the cubic root for the function, for the equation that I have got. So t is equal to what? Cubic root of 2. What is that cubic root of 2? It's called the critical number, okay? Critical number. Now, we found the first derivative, we found the critical numbers. What do we have to do? We have to evaluate the function at the criticals and the endpoints. Okay, so f of cubic root of 2 I have to find. The endpoints are f of -2 and f of 1. I mean g, sorry, here g is given to us. That is g. Okay, it doesn't make a difference because the function is given like that. Okay, so if I put cubic root of 2 into the function, what will I get? I will get the function was 8 multiplied to cubic root of 2 minus cubic root of 2 to the power of 4. Okay, here I will get 8 multiplied to -2 minus -2 to the power of 4, and here I will have 8 multiplied to 1 minus 1 to the power of 4. What will I get? G of -2, that's equal to -32. Okay, G of 1, that's equal to 7. You can find the value of this one, but if you look at that function, of course for this one you need a calculator. If you look at this one, that is the minimum value. Okay, that's the smallest value, and that one is the greatest value. So we say that x equal to -2 is global minimum and x equal to 1 is global maximum. That's the procedure for finding global maximum and global minimum, but we haven't talked about the relative extrema, relative minimum and relative maximum. There is also another example given in the course material. It is also solved. You can do it yourself. That's all for today's lecture. I mean, for that section. Hope you will understand it. Have a good time and bye-bye.